Okay, so today we are going to use the label indications node to find indications in a 1D scan of a swept-faced array, and we're going to use the internal tree of the labeler to gather some information about those indications. So we will get started. Open sweep. And that's our sweep scan we've collected, and I'm going to add a sweep correction to it. I'm going to change the output configuration just to keep my trees simple, so I'm only looking at the sweep. I'm just going to run that, and it looks fine. And I'm going to add 2 more nodes in the external tree. And label indications. So the median I'm going to rename as background, and I'm going to change the processing axis to third. And what that means is it's going to go in the out of plane direction, and for each point here it's going to take the median value through the depth. And we'll run that and drag it out. And you can see it's basically, those are the standing waves. Those are the waves that are there on typical A scans. So good to know that. The label indication, I think it's the default properties are good enough, but we'll put the threshold down to 25 and let that run. And if we scroll through this, you can see that it's picked out blobs or indications that are over 25%. And if you double click on the table icon, you can see that it's gathered a bunch of information about these indications, including position and amplitude and average and size and number of hits and things like that. But we do want the opportunity to add our own columns to that table, features of those indications. So this is how we do that. Add internal data loop. You see we've got the internal folder icon, split our manager, the labeler drags onto the output there, and we've got an internal loop. So what this indication loop does, and is it runs after the labeler has found all the indications. It passes each of those indications, a little box containing all the data, through this tree, and it gives us an opportunity to do data processing on the box, gather features of them, and put them back in the table. And this is how you do that. So I'll start by building the tree, and then we will sort of change the properties to get it to work. So bscan, so extract bscan goes on this. I think I can run it once to get the data objects to show. Indications, orientation 2D can go on there. Do a estimate 2D onto the bscan again. Amplitude on the extract indication, amplitude on that amplitude, and peak width 1D. So nearly there. Background, indication background, that one goes right on the internal data loop. And we'll throw on an indexed merged just for fun. Okay, so let's get this set up. So extract indication is the node that will go up to the labeler and for each point in the loop it'll pull out the indication and crop it down to the size of the indication. I'm going to change these properties just to add 2 millimeters of padding on each side. We can do 4 at the end. The masking mode is worth knowing about. It's basically saying when you give me a crop, if I do none, it's just the straightforward volume of data. I'm going to say crop other indications, and that's saying give me all the data, but if you're running into the next indication, set it to undefined or set it to 0. There are other modes. For instance, just give me the indications, set everything else to undefined. So I'll do mask other. Extract B-scan, I'm going to say give me your peak position, so that's the peak up and down the scan axis. The indication orientation, so we're going to the peak position, and then we're going to look for the orientation, but the orientation needs a threshold. Decimate, we are going to say limit your output size. Why don't we do 48 by 48? And indications background. How that one works is I drag the background noise source standing wave signal from there onto there, and that one is aware of the label indications, and when it gets past the indication, it will take the shape of the indication and go look for the signal in the background thing. So you can go and look at other points in the tree. They need to be the same shape and so on. There are restraints, but it'll tell you if it doesn't work. And the indication index merge we won't worry about for now. So let's just run the labeler again. And you can see that it's showing as it walks through all the indications. And that's a feature you might want to know about. It's good to know about. It's probably, what it's useful for is it just lets you double check what you're doing. So if I run this one again, I've dragged out the peak at B-scan, and it's going to do the labeling and then run through those. And you can have a quick view of what's happening, and you may catch something going wrong, but typically you want to turn it off. So update while looping, false. Okay, so and that speeds it up quite a bit, obviously. So another feature to know about is you can run this loop on one indication, and that's a useful tool for debugging the tree. So if we do execute once, first indication, that's fine. And now this tree has been run on this indication. So you can see that's our indication. And this is our indication. That's what this one had done is collapsed along the first axis and then the first axis again. But that's the second axis. So you're just left with the scan axis on this one. And then we're doing the peak position of that. And what that will give us is the peak position along the scan axis, the length on the scan axis. I'm going to do maybe 3 dB just because it might get not drop to 6 dB on the ends of this. We can look at the B-scan at the peak. It's calling it 149 degrees. This is the B-scan at the peak. And this one has been resized to 48 by 48. And I'm just going to drop that on my index merged. And okay, so that's our tree working. Let's run it again. And interesting that I've dropped the decimate on the index merge, and then you can sort of do a fly through. That's captured a thumbnail of each of the indications. The reason I use the decimate is to normalize the size. The indication index merge won't accept, it won't add a data line if it's not the same size as the if they're not all the same size, and the indications come in at different sizes, so we have to normalize the size. Okay, so our next job is to get these into the indications table, into this table. We're going to be adding a bunch of columns to the right here, and this is how we do it. So the first thing is you can't forget this because it won't work, is sync output usages, because we're going to use the usages on the outputs, and this one will clear them off if we don't do that. And now we're going to start putting the names of the columns in here. So this one, why don't we call it scan length? Okay. Okay, so on the indication orientation, probably we are interested in capturing the rotational angles, so we'll just take that one out. I've got my sync output usage false, and I'll put the, I don't know, angle. And decimate we're not interested in. How about the maximum of the background? Background max, and that'll do for now. I think is our output usage is false there, so I think we're good. So now we want to tell the labeler to go and get those points in the tree. So we can do that by hand. We can go to indication data columns and add in the column there. And this is just a comma separated list of columns that it knows to find. But there is a task for that, so that is find internal data columns, and that looks pretty reasonable. I think those are all the ones we did. So let's just let that run, and it should go through the tree, and we'll look and see what happened. We didn't get our indication, so let's figure out why. So I think I'm just going to try running from the root, because maybe some of the other stuff is not fresh anymore. So we'll let that run. And did we do it? We did. So we've got angles, we've got the length along the scan axis, and the background level there. Okay, so I think that should be good for that video. That's quite a lot of stuff to go through, but obviously you're only limited by your imagination as to what you put in here and what you pull out. And I think that's all for now.